Alright everyone, we're going to go ahead and start off Chapter 5 by first introducing you to a quadratic function. The best way to do it is with a picture. So we've got four different graphs here, the graphs of quadratic functions, and understand that y equals x squared. We do want to start writing that in function notation. So in order to write that in function notation, we can write f of x. Remember, f of x is the same as y. So f of x set equal to x squared. That is the same thing. F of x, same as y. Whenever you make a table, we are going to start making our tables with the x and then the f of x. Okay? Just to reinforce that that really means y. So with all of these graphs, what we're going to do first is just name three characteristics of the quadratic functions. The first characteristic is going to be the shape. It is U-shaped, okay, or the upside down U. You can see that just by looking at all four of these graphs. We have the U and the upside down U, and we're going to talk about how to determine which way it goes later. In addition to the shape, you also have this special part right here. This is the lowest part of this quadratic function, the graph of this quadratic, called a parabola. We call it the vertex. So the vertex here, which is a minimum, that's a minimum value, when I say lowest part, minimum, 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 and maximum. So the vertex is that point where the graph changes. See, it's going up, going up, going up, going up, and then it changes and starts to go down. So it is that point where the graph changes, the maximum here. In addition to that, you have the direction, which way it opens. So over here you see shape, direction, and vertex. You can also look at the y-intercept as well. The y-intercept is where it crosses the y-axis. Understand here, it does cross the y-axis at the vertex. That's just a coincidence. Here it crosses the y-axis at 3. And then here it crosses the y-axis at about 2. So you have the y-intercept as well as the x-intercept. So there are many more characteristics that we're looking at here. We're going to go ahead and discuss that x-intercept now as well, because you can see we have one x-intercept here, we have two x-intercepts here, or two solutions, also known as two roots. We have none here, and then we have two here. So throughout the course of this chapter, we are going to learn different ways to determine the x-intercepts and different ways to represent the quadratic function. So how many times does each graph intersect the x-axis? So really, it depends on how many solutions there are, because the x-intercepts, after all, are also known as the solutions. So right here, we have one x-intercept. We would call that one solution. Here we have two x-intercepts. We would call that two solutions. Here we have 0. We would call that no real solutions. And they would have imaginary roots. And then here we would have two solutions. Okay, two x-intercepts. All right. So how is the graph of y equals negative x squared minus 2x plus 2 different from the graphs of the other three functions? So let's go ahead and take a look at that right now. You can see that this one is frowning. We call it the upside down U. It is frowning. And if you'll notice, it is the only graph that has a negative with the variable that's squared. In this case, we have x. So we could call that negative 1x squared. We call that negative 1 the leading coefficient. Leading coefficient. We also could call it the a value because all quadratic functions can be written in this standard form. Remember, we had standard form for a line as well as slope-intercept form of a line. So we have the standard form of a quadratic function. The standard form is, it would be f of x equals ax squared, a times x squared, plus b times x plus c. Now understand, I put parentheses around there to reinforce to students that that we are multiplying a times x squared, b times x. You do not need those parentheses there. So when the a value is negative, it's going to frown. And that kind of answers another question that's asked later. When the a value is positive, so here the a value is positive 1, it smiles. And it can be positive 6 or positive 8 or positive 200. It's still going to, that would be a very steep graph, very steep parabola. But it would still open up. We say open up, opens down, right? Here we have a 1, that leading coefficient, as far as the a value is positive, so it opens up. And here, that a value, once again, a positive 1, it opens up. So we've made that conjecture really about why the graph of y equals negative x squared minus 2x plus 2 is different from the other graphs. We've answered that. That can be formally stated here in for questions 33 through 40 all in tonight's homework, or last night's homework. Identify the leading coefficient, which is the a value. This is how to determine whether or not a graph has a maximum or a minimum, right? If negative, then the parabola opens down. If the a value is negative, it opens down and has a maximum. Down maximum. If the a value, they're talking about the a value here, that a value, I'm writing in black so you couldn't see it, okay? If positive, they're talking about that a value, okay? That a value. Then it opens up and has a minimum. Opens up, smiles, and has a minimum. Real easy way to remember this is if it opens down, right, it frowns, okay? Opens down, it frowns. Okay, and then you can identify the maximums merely by putting your pencil at the peak. And understand it doesn't have a minimum because these lines mean that it extends forever in a downward direction. That's what those lines mean on the end of it there. So the example that I show right here, number 40, one of the tougher ones, we have the negative quantity of 4x plus 1 multiplied by the quantity x plus 4. How's this going to look after we convert it to standard form? Well, the first thing that I would do is I would FOIL. Because I'm allowed to multiply in whatever order I want to, I would go ahead and FOIL these first. Okay? I would multiply 4x times x to get 4x squared. I would multiply 4x times 4 to get 16x, and then I would add that to 1 times x, because of the like terms there, to get 17x total, and then I would multiply the 1 times the 4 to get 4. So first, outer, inner, and then last, for those of you who've been away from algebra for a while. Then I'm going to distribute that negative through, negative 4x squared minus 17x, and subtract 4. Of course, when I distribute that negative, I now see that my leading coefficient, okay, my leading coefficient is negative. Perhaps I should be drawing in that other color that I drew up here for the maximum. So I can see that leading coefficient, that a value is negative. If the a value is negative, I'm certain that I'm going to have a maximum. Okay, it opens down and has a max. So that is how you determine whether or not the graph of a quadratic function, which way it opens, and whether or not it has a maximum or a minimum. I'm going to go ahead and just show you. You can pause to actually see how I did the problems, show you the problems that we went over in order to keep this video shorter than 11 minutes. So I'm going to go ahead and you can pause here at any time. You can just see what we were doing here. We were using the distributive property. We also used FOIL as well. You'll see that we also used, for number 4 down there, we did use FOIL. To use the distributive property, what you're actually going to do here is you're going to multiply that x times the quantity x plus 1, and then you're going to multiply the 1. Oh, Mr. Claxton, you made a mistake. It's okay as long as I go back and correct it. Going to multiply times the quantity x minus. So frazzled, made another mistake. All right. I'm going to multiply times the quantity x minus 1. So I'm going to take this, multiply it by this quantity. I can use the cover-up method, cover up the 1, x multiplied by x minus 1. And I'm going to cover up the x, multiply the 1 times the quantity x minus 1. So I'm going to add those together. X times the quantity x minus 1. So you can see how I used the distributive property twice over. I'm now going to get my final answer. Well, not my final answer. So it'll be x squared minus x plus